Okay, here's page three, part three. Let's talk about some common phenomena, including points, lines, and planes. Now, we covered a little bit of this before. Again, this is going to be like a true false, but in the end, like it's just really covering phenomena. So let's jump into it. All right, so decide whether it's true or false. If it's true, provide an example. If it's false, explain why. So, is it possible for a set of 3 points to be coplanar but not collinear? So, let's just draw it out. Let's just pick 3 points first and see what we get. So here's point one. That's a bit wimpy. Here's point one. Bam. Point two. Point three. Now, I intentionally drew them so they weren't collinear. That would totally cover the second part of that question. So what I'm questioning now is, are these 3 points going to be coplanar? Well, as we talked about before in part one, it's actually impossible for them not to be. So if you kind of consider, I just pick kind of 3 points out in space. Knowing what I know about lines, I can totally make sure that this is a line by picking all the collinear points. If I connect these two kind of in the same way, and these two in the same way, I've actually forced all three of these points to form a plane. So I've now defined in 2 dimensions a nice flat surface. So by actually making them non-collinear, we force them to be coplanar. So the answer to this question is actually yes. Um, Here's an example of what I mean. In fact, it's impossible not to. Okay, so this is actually one of the basic rules of geometry. Any 3 points will form a plane, and so you're kind of seeing here kind of fleshed out. So let's go to question number two. Is it possible for a set of two lines that are both coplanar and parallel? Well, let's first start by just drawing them out. Let's draw a set of lines. So here is line number one, and then here is line number two. Now I know it's not perfect, but again, this is just kind of the idea. These are parallel. So the question is it possible for these to be coplanar as well? Well, it turns out like this one of these things again where the answer is yes. It's not only possible, it's impossible not to be. Okay? Now this example is a little bit convoluted, but let me give you a better one. I'm going to go to a cube or a box. I think in this configuration, it's a whole lot more clear what I'm talking about. If I just pick out two lines that are parallel, and I'll hide them in red. So let's say I pick out this line on the top, and let's say I pick on this one on the bottom, which doesn't appear initially to be coplanar, because you kind of expect me to pick this one to be non-co or to be coplanar. I would argue you can totally find a plane between those two just by connecting them. So like we can actually find a plane even though these parallel lines they don't initially appear to be. There's totally a flat surface that contains both of those guys, albeit right through the center of this box. But we're not inhibited by such things. Like we're just looking for planarity. Like we can go right through surfaces. You can see this is true for pretty much anything. Like pick any two lines here that are parallel. I can find a plane that goes between them. Like here, let's pick the one on the top back, and let's pick one on the bottom back. Well, not only these are parallel, we actually have the back itself that helps define that plane. And so, again, I would claim it's impossible for two lines to not be parallel. Let's see, one on the front side, one on the back corner. There is totally a plane that exists right between them, that goes right through the center. And again, it's impossible for them not to be. So again, the note here is that not only are two parallel lines, not only can two parallel lines be coplanar, they have to be coplanar. It has no choice. Now, before you think that's a theme, let's check out number three. A set of 3 points are both collinear and coplanar. Well, first let's pick out 3 points. Hold on. Womp. Let's pick out 3 points, one, two, three, and let's make them a line. And so let me go a little bit thinner here. Okay, we have a line. Now the question is, does there exist a plane that these points are all on? It turns out the answer to this one's also yes. In fact, it's no one of these impossible to be. So check this out. So it could totally be like on this plane, but it'll also be like on this plane. And let me switch colors here. Okay. It could also be like on this plane that sticks out this way, or maybe this plane that goes up this way. So it's another one of these. Not only the answer yes, but it has to be. Man, these are almost like really important rules of geometry. Like 3 points always make a plane, two parallel lines are always coplanar. Points that are collinear are also by default coplanar. How about this one? I set up two lines that are parallel and not coplanar. Wait a minute. If we just set up here that it's impossible not to be, I would say here the answer has to be false, or the answer is no. Because if it has to always be coplanar, then it can't force it not to be. If you kind of think about non-coplanar lines, and again, I'm going to go to a box to help kind of guide this explanation. If I pick out two that are non-coplanar, let's say this guy and this guy across the back kind of side, well, the only way that these can be non-coplanar is if they're non-parallel, because I can't define a surface between them. If I were to put a single surface between these two lines, it would actually have to twist, and you kind of think of like a piece of cloth that I kind of attach right here, and then I also try to attach right here. There's going to be a big wicked twist right in the middle of it, and that's why it's going to be non-coplanar. Let's look at question 5. A set of 3 points that are non-coplanar. Now, if you're paying attention or watching maybe earlier video, we actually kind of covered this. If I take any 3 points and just kind of draw them out so they're non-collinear, because up here, if they're collinear, they're automatically coplanar. I'm automatically defining a plane between them. So here, here, and here, that's a plane. Like that's a flat surface right there. All these lines by definition are coplanar. So the big one is this is false. This is actually a anti-example or the non-example. Okay. So moving on, number 6, a set of 2 points that are non-collinear. Again, an earlier portion of this video covered this, but hopefully it's not new to you. If I just take 2 points, boom, boom, it's absolutely impossible to not be able to draw a line between them. So I would say again, this one's false because it is impossible not to. Okay, so that's the end of what's this, page 3, part 3 of the video. Really short, just kind of giving you some big general ideas about geometry. So I'll see you guys in part 4.